Recording. Okay. So thank you so much for joining us today for navigating AI tools for biomedical literature searching. As I said, please feel free to use the chat throughout. We'll monitor it. My name is Robin O'Hanlon. I'm the Associate Librarian for User Services at MSK Library. My co-instructor is Joanna Goldberg. Joanna is a research informationist or reference librarian at the library. So let's go ahead and get started. So we wanted to start off with some audience participation. Please use the chat to answer these questions. We really want to hear from you. Do you currently use any AI tools to navigate the biominiature literature? Yes, no, not yet. And if you are using any, please let us know which ones you're using. We always like to ask this question so we know what resources we at the library should be learning more about. Okay, great. So I'm seeing some yes, no, yes, ChatGPT, Perplexity, AI, administrative lying. Okay, yeah.
Kristen, I want to talk to you about perplexity a little bit.
Yeah. So we'll get into some of that today.
Julius AI. I don't know anything about Julius AI.
Yeah, so this is why we have to be taking notes, Joanna, on
We
our
do. We do.
Okay, so I also, while you're doing that, I just wanted to sort of clarify a bit in terms of the focus on this session. We're mostly going to be talking about, when we're referring to biomedical literature searching, we're mostly focused on sort of exploratory searching that a researcher would conduct for general understanding of a particular topic, so kind of background research. We aren't going to be talking about AI tools for larger scale evidence synthesis projects like systematic reviews or scoping reviews or meta-analyses. There are a lot of sort of exciting developments in that area, but also some big causes for concern. And it's kind of beyond the scope of what we'll cover today, but we are considering offering another class on it in the future. And we'll talk a little bit about using AI tools for sort of clinical and patient care searching in terms of like actual point of care settings and clinical decision making. But again, this is sort of an area where we need to proceed with caution because, as I'm sure you're aware, what generative AI is really doing, and if you see this slide, it's basically attempting to kind of find like a middle ground. And we should just sort of back up a second and define generative AI and how it relates to large language models. So we know we have large language models, which are a subset of machine learning models trained on these vast amounts of text to understand and generate human-like language. So the most well-known at this point is obviously OpenAI's GPT models. And generative AI is a broader category of AI that generates new content like text and images rather than just analyzing data. And the products we're talking about today are generative AI tools because they don't just search and analyze data, they are summarizing it. So they're generating new content. And so we should be clear, though, even if you haven't adopted one of these tools, generative AI tools, for use. You're probably using some type of AI when you're searching the biomedical literature already. Like if you use PubMed, even if you're not using the best match filter, if you search with mesh terms, and Joanna will tell you for better or worse, machine learning is used to assign mesh terms for indexing. And there are many different kinds of AI incorporated into the research environment that you're all working in. But when it comes to generative AI, and we learned a lot about this topic from Carol Choi, who's a data reference and collections librarian at NYU, she reminded us that generative AI is not an information retrieval system. That's not how it's designed, and it's not how it's functioning. It's built with this three-step process that I'm sure you all know is they're breaking the data down into these smaller fragments or tokens and stripping the semantic meaning away, and then they are and then the tokenized fragments are developing like a statistical model of language. So this is why we should kind of avoid anthropomorphizing when it comes to generative AI. It's not really thinking, it's processing, it's not hallucinating, it's just kind of making patterns. It's not really, it's doing sort of, it's not looking for the right answer. It's looking for the most statistically probable answer based on its training. So it's not really doing what you think it's doing, but it's kind of pretending to do it, and it can do it pretty well. So it's really about prediction. It's not about retrieval. What's kind of exciting now is that for some generative AI products, the corpus that it's being trained on is improving, and companies are starting to become more savvy about what's being pulled into the corpus. And that can include more authoritative sources. And it's really, so this, it all kind of comes down to it being about the data source. So a good rule of thumb at this point is generative AI will kind of get you like 70 to 80% of the way there, but it still requires human monitoring in a meaningful way. And at this point in the game, at this stage in the game, that monitoring can maybe be as much work as completing a project without you using generative AI. It really depends, but we really do need the ongoing monitoring, or we end up with things like, next slide, please, like this. Did anyone hear about it? You can like raise your hand or tell us in the chat. So this mouse image was published in Frontiers in Cell and Developmental Biology last year, even though it's like clearly AI generated. It was not surprisingly, the article was redacted. So this was a generative AI image tool, and images can obviously be very obvious, like they're obviously problematic compared to something like article summaries, but regardless of what AI is generated at your request, you still need to monitor and review it. And the onus is, of course, in the end on the person using the AI, not the AI itself, to ensure accuracy. Next slide. So this kind of brings us to AI for reviewing the biomedical literature. This is from a Nature article that was published last year. And as with many things related to generative AI right now, the answer is kind of it depends. So key questions we kind of need to ask ourselves are these tools being used critically with adequate quality control and adequate monitoring? At what point are they being used? Like at the beginning of the review process or kind of to fill in gaps? And then is their use being disclosed? So transparency is really key throughout the process. And this quote from this EBM researcher, I think sums it up nicely. It's kind of where we are now. It's this double-edged sword in the current era. AI can enable researchers to produce high quality reviews, and it has. But without proper controls, it can also allow researchers to generate a lot of really substandard reviews. So it's hard to kind of know at this point what the net impact is going to be, which sort of brings us to ethical considerations, and I'll let Joanna talk about that.
Thank you, Robin. So we're going to break ethics up into a few subtopics. We're going to look at what MSK is saying first. We're going to look at some privacy and copyright issues and things about transparency. And we're also going to look at environmental factors. So I pulled these next two slides from 1MSK. If you haven't looked at these 1MSK sites, I recommend it. There's some really good information there. And it's good to know that people at MSK are really thinking through the use of AI in work. This criteria and the next slide as well are mostly about clinical tools and less so about literature searching, but I think the same rules still apply. And we have to ask ourselves the same questions. So the next slide is going to show those ethics. And then the adoption trait methodology is an article of a validated instrument that was published by MSK researchers to try to determine clinical uptake. But these questions are so important for how we relate to the AI we're using. How much help will it be? What are the privacy concerns? What's the risk assessment? Is it valid? So I recommend coming back to this anytime you're thinking about adding an AI tool to your workflow in any way, be it literature searching or something else. And then we have these ethical values and guiding principles. And I find number 3 and 5 really stand out to me. So are the generative AI tools you're using safe, secure, accurate, effective? Are they transparent, explainable, and intelligible? And if your answer to these or any of the other questions are no, or I'm not sure, or kind of, or I think so, you really have to question why you're relying on them and the extent to which you're relying on them. So more largely outside of MSK, generative AI is often using the data you give it to train itself. This isn't always the case. A lot of the tools today say they're not doing this, but I don't know. Sometimes I question if they are or not. So because of this, especially tools like ChatGPT are really famous for using the information you give it to train the system. Don't share anything private. Never give it PHI or health information of a specific patient. Don't share copyrighted information or drafts of papers you're working on or grants that you might be peer reviewing. The overall message here is that if you want something to stay private, don't give it to generative AI. And again, there might be less of an issue in the tools we're going to show today, but it's still something you want to think about anytime you're using this type of system. So a lot of publishers and other organizations related to scientific publishing have thought about generative AI use. I hope some of you have heard of COPE. It's an overarching organization of publishers and some other scientific institutions. And their guidelines are really similar to what a lot of individual publishers are saying about the use of generative AI, which is that if you use it, it can't be given co-authorship. And also you have to be transparent about how you've used it, what parts of your work are done through an AI tool. And if you are using it and you're not saying that you're using it, you might end up with an image of a rat with impossible anatomy. So just because you can get away with it doesn't mean you should get away with it. And honesty is always incredibly important in any scientific work. This statement comes from a blog post from an NIH department office. I always forget exactly what immunology, allergy, and the other one stands for, but it's that department. So they say, and I love this, that you share responsibility for ensuring integrity in the scientific review process, and we will hold you accountable even if AI technology is a source of noncompliance. You are the person, and you have the overall responsibility for ensuring that what you're saying is accurate. It doesn't matter if AI told you to do it. And we also see below that in all of NIH grant review, peer reviewers are not allowed to put grant applications into a generative AI tool. Does anyone have any comments on why that might be the case? Or is that something you've thought about doing or would never do? If you've never done it or would never do it, I'm so glad to hear it. They're very concerned about privacy, about training, and they don't want data from grantees or potential grantees to become part of AI training data. Okay, so you've probably heard about AI and the environment. This is a graph that was recently published by Nature News, and it's thought to be an underestimate, what they're listing here. So the amount of energy that's used by AI, by generative AI, can be massive. You can see here that if you're looking at if you're looking to create text or to summarize information, it's somewhere around how much it would take to charge your phone or to run a laptop. And if hundreds of thousands of people are doing this every day or maybe multiple times a day, you can just think about how much of an impact that would have. So I am going to switch what I'm sharing and show this very short video. Just bear with me as I find my browser. Okay, seconds. Sorry. And here we go. I'm sorry, there's no sound. I'm sorry, there was no sound. I hope you were reading along as you couldn't hear. Next time we do this, we will have sound for sure. But as usual, it's the areas of the world that need the most help that are probably getting the most harm from technology like this. So I always try to think, do I really need to run this question through a generative AI tool? Will the time that I save be worth the water that ends up being wasted? And hopefully at some point we'll figure out a better way to do this that is not so environmentally harmful. Okay, we're back to Robin.
Thanks, Joanna. So we're all kind of, as researchers, we understand the importance of asking questions, fundamental questions about information resources, and we can think and apply these all to generative AI tools for biomedical literature searching. So things we can ask are like, who's managing the tool? What are their goals? Is it to promote open science? Is it to make money? Is it both? What are they promoting? Resources from a single publisher or database? Is the information transparent? Are they transparent about their corpus and what's included and indexed within it? Where is the search taking place? Do we know, is this sort of shared or secret? Is the content being made up based on the likelihood of existing literature? And we know this is common with some generative AI tools and not as common with others. What was when was the literature that was published returned, when was it published? So do we know? Is there a given date range? Is it recent? How far back does it go? How is it being searched? Is the process not just transparent, but also reproducible? Like if you ask the same questions, do the results differ? And if your question, is your question going to be sort of specific enough to generate the answer you're looking for? And is this good enough for your purposes? Are you trying to explore a new topic, or do you just want to learn more about, or are you trying to like figure out a specific clinical question related to patient care, or like developing a clinical guideline? Next slide. So the number, and you all know this, I'm sure, and we got a little of this in the chat, the number of AI tools that can be leveraged for searching the biomedical literature has exploded in the past year. We're attempting to track these tools on our AI resource guide on our website, and we'll put a link in the chat. I would like to sort of draw here, maybe I can do that quickly. There we go. So if you go to the generative AI tab, I want to draw your attention to this chart that we are iteratively adding to at the bottom of this guide. And I just want to go over a couple of the key features that can maybe help you decide how useful these tools will be for your work. So the first and the most important is the data source. What is the corpus these tools are using? If you're going to have them summarize the literature or generate reports, this is really important to understand. So we'll come back to this. Then we look at the cost. Most of these products have some cost associated. Often there's free versions and paid versions, and you'll be limited in terms of like the number of queries you can submit in a given time frame. There's usually subscription tiers like free, pro, premium. And the library is to answer probably your next question, the library is just beginning to explore how we're going to handle, if we will handle licensing products like this as an institutional level. We have very like rigorous standards and sort of like in terms of quality control and what we can and what we're able to license. Then we have, moving further to the right, the ability of these tools to generate like interactive citation maps or network. And this is cool. Some of these AI tools like Research Rabbit can do that and help you visually map connections between citations. Can they analyze the abstract or full text of publications and use this information to provide literature summaries? Some tools can do this, others can't. We'll talk about those limitations. Next, will it provide answers to research questions? Like, can you ask it a question and it give you an answer? And with some of these tools, that's actually the best way to interact with them. And finally, can you upload PDFs or other references and have them extract the data from pre-existing like research documents? And then do they integrate with some form of reference manager like EndNote or Zotero? But going back to the data source, probably what you've noticed a lot is that a lot of these projects are using Semantic Scholar as their data source. So I'm going to spend some time describing it in detail. If you use these products, it's really important to understand exactly what you're searching. So what is Semantic Scholar exactly? So it's been around for almost 10 years. It was developed in 2015 by the Allen Institute for Artificial Intelligence, which was founded by Paul Allen, Microsoft Scion. It's a free AI-powered research and discovery tool. And the goal of the project was to tackle the information overload in academic research by using AI to provide more intelligent and relevant search results. This review on the right is actually from a librarian in 2018, and it's a little hard to read, but it says, features of Semantic Scholar are in keeping with the mission of librarians to save the user time. By limiting results, Semantic Scholar renews a scientist's joy of discovery once again. So it uses machine learning and natural language processing to enhance retrieval, but like, how does it do that? What does enriching the data, like AI enriching the data, actually mean? So it goes beyond simple keyword matching. Instead of just searching for papers containing search terms, it tries to look at the context behind the query. So if you are searching for, say, like AI in healthcare, it doesn't just look for those exact words. It's going to discuss similar concepts of related topics like AI algorithms in medicine or whatever. Semantic Scholar also uses AI to generate automatic summaries of research papers, including the abstract and the key findings and the conclusions. They call it the TLDR, too long didn't read version of an article. And it also, another key feature is our citation graphs, which are visualizations of how research papers are related through citations. And so it helps construct and update these graphs by analyzing the citation relationships between papers. What is in it? So as of 2025, it's home to over 230 million papers from a wide array of academic fields like computer science, biology, medicine. And the team behind Semantic Scholar is a big proponent of open science, and the aims are to make research more accessible. They're very committed to open access research. So they're highlighting and prioritizing freely available research and also allowing users to read and download full text without paywalls. So what you get a lot of are papers from open access publishers like PLOS and Biomed Central and Frontiers. Semantic Scholar also indexes a lot of preprints, which are typically hosted on platforms like medRxiv or bioRxiv. But if a research paper is published in a journal that's behind a paywall, Semantic Scholar can index basic metadata like the title and the abstract and the authors, but it doesn't have access to the full content or the full text of these papers, right? So it can't provide a full text search or an in-depth analysis of the content itself. And publishers, we know, like Elsevier and Wiley, they very tightly control how their content is distributed. That's how they make money. And they generally don't allow third parties like Semantic Scholar to access the full text without permission. So the AI-driven summaries of papers that Semantic Scholar generates can be helpful for, I think, for maybe like understanding maybe core ideas of a paper, but the summaries can't really replace the full text of proprietary papers. So this is like a good point, I think, to ask yourself, what do I need this information for? Like maybe I'm okay with just the information from abstracts. I'm just trying to explore a topic. Or maybe that's not sufficient and I need to dig a little deeper. We know research published in high impact subscription-based journals often represents like cutting edge studies or long-term investigations with like large data sets. And those are key sources of evidence. And by not indexing these papers fully, you're not getting like the most comprehensive view of the literature. So I think for now, it's this very powerful tool for discovering open access literature, but it's going to miss a substantial portion of high quality evidence. And that can kind of limit the breadth of evidence that's available to users, especially in fields where subscription journals are still very dominant, like cancer research. So it's, I think, best used, it and tools that leverage its corpus are best kind of used as a complementary tool with other resources like institutional access and publisher sites like clinical trials databases. These need to sort of fill the gaps when the subscription-based content is still necessary. And we know like this is not ideal for researchers. It would be so amazing if like real federated searching and open science could be like fully realized, because full text searching is very fragmented. Each content provider has its own database, and you generally can't search across all sources at once. So if you're doing a full text search, you're essentially searching like within a silo of a given platform. It's not like PubMed is searching the full text either. I mean, PubMed Central is, but that's 5 million articles compared to like 230 million in semantic scholars. So I get it. There's like tremendous opportunity, but we just want you kind of to be aware of what it is and isn't summarizing. And we're really curious if this like desire for high quality AI evidence summaries is going to move the needle on open access publishing, because the more open access content that's available, the more AI tools can be trained on it. And as more open access research is fed into AI systems, the knowledge base will grow and make it more useful. And we know, as with just like with subscription-based content, there's a range of quality when it comes to open access research. Like there are high quality open access journals like IEEE. And then like there are some frontiers journals where you get the mouse with the like impossible anatomy. So we're gonna like dive into these tools now. I think Joanna's gonna show you consensus first.
Before we do that, Robin, Kristen, I always pronounce your last name wrong. I'm sorry. Um, she wanted to know if NIH public um, access versions, so PubMed Central versions of articles, are included in Semantic Scholar.
I'm not sure. That's a great question. I'll find out and get
On
back
the
to
chart, there are some sources that say PubMed Central, which
you.
would
Yeah,
include those NIH version, the NIH public access version of papers. Yeah, but I'm not sure if they're in Semantic Scholar or not either.
we'll investigate, Kristen, let you know.
Okay, so I signed up for a free Consensus account. Consensus is one of the many generative AI tools out there. And I got this email, and I really want to know what you think of it because it made me make this face. So it's saying why we need tools like Consensus. I love that it's saying tools like and not just boasting about itself completely. Scientific literature is tedious to search through and extract insights from. Traditional tools like Google Scholar or PubMed don't make life any easier. General purpose tools like Google or chatbot like ChatGPT are built using the entire internet and have significant limitations. Consumer tools simply aren't built for research, and research tools often have clunky interfaces and lack innovation. We believe there's a better way. So what is your initial thought to that PR speak? Is that PR speak, marketing speak? I think as a librarian, I'm a little biased to think, do you know what life was like before we had online databases? When we had volumes of books that were published on an annual basis saying what was added, and we'd have to go through every volume from every year. Anyway, so I appreciate that they're saying that they're a step forward, but I question if what they're saying is actually true. So there is a free version of Consensus available, and I'm going to put this URL in the chat here if you want to follow along. We are going to also look at these questions, which I'm also going to put in the chat. And let me go to Consensus. Okay, so here is what it looks like before I log in. And if we want to know what sources are searched, I'm going to click About and see what they have to say. Go to their FAQ. Okay, so it's saying the type of technology they're using, and yes, they're using Semantic Scholar. So what would that make you think about using this tool, and in what circumstances you might use this tool or not use this tool? And while you're thinking, I'm going to log in. That is not the password. Okay, one thing I do like about Consensus is that there's a limit to the number of questions you can ask it with a free account, but it remembers what you've done. So I don't need to ask the same question over and over again, I can use what I did in the past. So I decided to ask it about the most recent data about the success rate of cryotherapy in cancer treatment. And here, what I also liked is that you can put in filters. So the first time I did this, I didn't have a year filter in, and the most recent data was not very recent. But when I put in that filter, it made it from either 2024 or 2025. So I am not an expert in this field by any stretch of the imagination, but we can at least see what it's doing. So it's breaking it down in a sort of nicely organized way by different types of cancer. It's giving these citations, and if I click, I go right to it. It even says what type of study things are and what year things were published. I haven't checked to see if they're correctly determining the study type. That is often an issue even by the people who write studies. They don't always give the right study type because it can be confusing. Um, so it's a very sort of succinct summary. But the question is, do we know how consensus found this? I do know that it remembers this search. So if I go back in again, it will give me the same response to the search unless I change the filters. So at least in the short term, it's a reproducible tool. But I don't know how it decided which of the most recent literature to use to make this summary. Are there questions or things you've noticed if you used consensus or anything else you'd like me to look up while I have this open? And I just want to be clear that I'm not saying you should use this tool. We just selected a few tools to use as samples. Um, I would have some, I would want to look at the source material to make sure that the summaries it's giving are accurate. I think maybe if it's a simpler question with more clear sources, it's probably going to do a better job than if something is perhaps less clear in the literature. But again, I haven't done enough looking around to know for sure if that's true. Are there tools to evaluate these tools? Okay, I love that question. I know that there is that one tool that I mentioned in the ethics section that MSK came up with to evaluate like clinician acceptance of AI tools. I'm not sure. Do you know, Robin, if someone has come up with a bias appraisal or a quality appraisal tool for AI tools themselves? And if not, should we do it?
Yes, absolutely. I don't know. That's a great question, and we'll look around and get an answer for you. But if there isn't, I think there's um
I
I think
think part of it is asking
yeah.
it some of the questions that we have on that who, what, where, when, why slide. If you're not sure, it's a question. And also the question is, how good does my project have to be? Like if it's something that you're just trying to get a feel for a topic, maybe it's okay. Have you ever tried to look for references to fit into certain statements? I'm not sure I understand that question.
I think we're going to look at another tool. We'll think about
Yes.
that. And so now we're going to look at Elicit, and let us know in the chat if you've used Elicit. I will go ahead and just share my whole desktop here. Okay, so Elicit, like Consensus, is drawing from Semantic Scholar. It was founded in 2018 by a team of sort of researchers and engineers. So we can put a link in the chat. See if I can. So there's a free and paid version. You can see the pricing here. So and sort of what differs are the number of summaries you get and the number of papers you can extract from. So the free version gets you unlimited summaries for 4 papers at once. And you can extract data from 20 papers per month. You're kind of limited in terms of what you can export in terms of tables and RIS files. So frankly, the free version is pretty limited. But for now, already you can try signing up for a free account. While we do that, I also just want to explore the FAQs down here at the bottom. So these are helpful. What types of data does Elicit search over? You can see it's including 125 million academic papers from Semantic Scholar, so a subset actually of Semantic Scholar. And it says when you extract data from papers in Elicit, Elicit will use the full text if available. So that's most likely an open access publication, and the abstract if not. So that's probably that's subscription-based content. How accurate is it? A good rule of thumb is to assume that around 90% of the information you see is accurate. While we do our best, blah, blah, blah. It's very important for you to check your work in Elicit closely. And so, yeah, I mean, I think this is, again, it's coming from the horse's mouth, right? This monitoring is important. The last thing you can look, I wanted to show you here are if you end up using it, the help and guides. So this is their help center. It's actually pretty useful. So if you look at About Elicit, you can see again, it's sort of recommendations for citing Elicit content. So they say that they don't recommend copying, pasting Elicit summaries verbatim. To minimize hallucinations, Elicit summaries stay faithful to the source text as possible. So it's basically saying you could be plagiarizing if you are using these summaries like directly, and that AI writing detectors may pick up on that. So that's good to know. And just some information about their limitations. Again, they say that, so here they say it's 80 to 90% accurate, definitely not 100% accurate. And they make, I think a solid point is that it's only as good as the papers that are underlying it. And they don't know how to evaluate whether one paper is more trustworthy than another. So they're doing their best, but that's what they have. And it also works better with some questions and domains than others. But looking just at the tool, if you've logged in and you have an account, the interface you'll see is super straightforward. There's basically 5 things you can do. You can find papers, get a research report, start a systematic review, which you can only do if you have the pro version, extract data from PDFs, and then list concepts. So I'll show just a quick example. So the first thing Elicit is going to do is going to sort of evaluate sorry, I'm clicking around everywhere, your question, right? And if it thinks your question is sort of specific enough, it'll say, great question. If you have a question that isn't as well formed, it's going to analyze that and give you some suggestions about how to make it more precise. And then you can search. But we will go back and use our original question about low-level laser light therapy, quality of life. And the first thing it's going to do is basically generate a summary for you. And of course, we're using the free version, so you're only getting a summary of the top 4 papers. And you can click on these titles and it will take you to the abstract, and then you can see, you can go directly into the primary literature by clicking source. This will download a PDF for you of the article, or it will take you to the publisher's website. You can also see here so we have these columns, and on the left is just information about the paper, the title of the authors, the number of citations that it has. This is the AI generated abstract summary that Elicit is coming up with. And then you can add these different domains, and there are tons of them. So if you're interested in, for example, like region, you can add this and it will pull out and extract the region that was of study in the particular article. And again, like everything will be limited sort of based on what type of account you have. So I think at this point, we reach our limit pretty quickly with the number of domains we can add with the free account. You can filter by most relevant, most recent, most cited, and they're using semantic scholar citation information here. You can filter by publication year, journal quality. They're using SciMago's journal rank measure. Study type, you can enter keywords in terms of the abstract. And then if you have the pro version, you can export this as a table, which is kind of a nice feature. So those are the basics of searching, finding articles, right? So you can also then add steps going back. So you can generate a research report, which is essentially kind of like a souped up version of the table that they created. And it takes some time, so I'm just going to show you a version of one that I already did. So this is interesting. It shows you sort of at every step what Elicit did and how they generated this report. And you can look at, for example, the screening criteria that was included, how they were defining the extraction. And if you have the pro version, you can edit, you have total control, and you can edit all these earlier steps, like making changes in screening criteria, screening more papers in and out, adding or removing like data extraction columns or changing column instructions. Elicit also has the ability going back to extract data from PDFs, and you can upload a number of PDFs at a time, and they will all be stored in your library. So here's an example. And so you just have to go, and then once you've extracted, select, and then go over. Let's see, I'm like struggling with seeing things on my screen here. It's the same thing, basically. It will pull out information and put it into a table for you, and you can specify sort of like how many, you can select preset domains in terms of like methodology or interventions or region. You can add domains. There's a high accuracy version that only comes with the pro version. So I don't know what you're getting if it's not high accuracy. Hopefully it's just accurate. But then you can export this as a CSV if you're a Plus subscriber and share it with your colleagues, and they sort of recommend that you maybe have use this as a first pass and then have like a research assistant double check the work. And there's a lot more features that I don't have time to go over. There's a chat feature where you can once a research report's generated, you can chat and like ask clarifying questions or sort of dive into deeper topics. There's this other list of concepts feature that searches across papers and tries to find things like data sets across multiple papers. I think sort of the concerns that we have with Elicit now are the corpus. We don't exactly know what's in it. We know it has a lot of open access content, preprints. It pulls from abstracts of subscription content, but we don't really know what the breakdown is. And they won't provide us sort of a list of what's indexed. We just say there's this many million articles. Another thing that they don't seem to be doing well is flagging retracted articles appropriately. So just as an example, so here's an article that was published and then retracted. And I'm going to go back and see if I can find this. Okay, so it looks like it's taking its time, but yeah, so here's this article. It does a little abstract summary. There's really no indication that this was retracted, whereas if you search somewhere like PubMed, you will see that it was retracted. It's very clear. And if you go to the article of record, it's going to indicate it's retracted. So this is a concern for us because there's nothing to indicate that this article wouldn't be included in one of these evidence summaries. So it's really something that needs monitoring. And that's, you know, I think when they're saying like we're 80% there, it's like that's that's a lot of it. And this is just an aside. They're really trying to push their systematic review product, and they're not really following best practices in the realm of systematic review methodology for reasons that we don't have time to get into, but we can describe in great detail if anyone's interested. Joanne and I both attended a demo and came away with that general impression. And of course, you can't use it unless you're paying $50 a month for the pro version. And so I think, yeah, we're actively sort of like researching how best to evaluate tools like this. We have a couple more we want to share with you. Let me head back to our slides here. And so one thing that we talked about with Elicit, right, was this issue that, and this is very common, that they can't really parse out like they can't evaluate whether one paper is more trustworthy than another, except by giving some sort of like imperfect, like heuristic, like a citation count. So one product that has tried to sort of deal with this problem is Cite. And so rather than just hearing me talk, I'll like try to play this video for you. We'll see if I can get the sound to work. Let me know if it's working here.
Hi, my name is Josh, and I'm the co-founder of Cite. I'm also a cell biologist by training. Today,
No sound?
I can hear it.
Okay, great.
I'll walk you through how Cite can help you better discover, understand, and evaluate research. Say you've just come to this article published in Nature in 2010. You might look at a few things, right? Where is it published? Who are the authors? What are their affiliations? And then some metrics. Maybe you're on your way downloading the PDF and reading. If, however, you click through to look at, what is the literature saying about this, you might come to a citation index that will show you the list of citing articles, whether that's Scopus, whether that's Web of Science, or whether that's publisher produced. In these lists, we are treating citations as if they're all the same, as if they're flat. And that is not right? There are many different ways and reasons to cite an article. Maybe this one cites in the introduction section. Maybe this one cites in the method section. Maybe this one is presenting supporting evidence to the claim. Maybe this one is challenging it and directly refuting the claim. So with Cite, we want to make this information easy to digest and to understand so that you don't have to necessarily open 675 different documents, but you can get that insight in a very digestible and easy to use format. So if you look at this article through the lens of Cite, what you'll see is that we have basically the same metadata as the version of records, the title, the authors, the abstract. And then we do have a list of citing documents, but then unique to Cite, what we do is go into the full text and extract out the exact citation statements where that article is being cited, right? So here's an article that cites it in 4 different places, 2 times in the results section, 2 times in the introduction section. And here is exactly how it's cited, right? So this little excerpt comes from the results section, and they're saying, in agreement with early reports, they cite the article of interest. They also cite this co-citation, so a related article, where they're agreeing with, right? We observed around 37% slower multiple turnover degradation, which they say is in agreement with early reports. This, the context, the where we've got that context from, and then that classification is collectively what we call a smart citation.
Okay, so these smart citations are distinguishing whether a citation is offering the supporting or contrasting evidence. And you can check this, researchers can check these metrics at the level of articles but also journals and organizations. They have a browser plugin that makes it pretty easy to use. It also allows you to upload a manuscript and see if references in it have been like heavily retracted or contrasted. But Cite is also not free. I should clarify, it's $12 a month. So there's that. But the last tool we're going to show you is free that we want to share with you. It's called OpenEvidence. So you can indicate in the chat if you've used OpenEvidence. So OpenEvidence was launched by the Mayo Clinic Platform Accelerator Program. Here you can see more about its team of founders. You can see it is supported by Sequoia Capital, which is a major venture capitalist firm. And hot off the presses, in February this year, OpenEvidence announced that they are going to be, they signed a multi-year contract that will allow them to use New England Journal of Medicine group content from 1990 forward. So it's free and unlimited for healthcare professionals. You just need to go to sign up and you have to enter your national provider identifier. So we at the library are kind of limited in how much we can test it. But like, so what is OpenEvidence doing? It is, I will see if I can log in here and remember my username and password. But basically what it's doing is similar to any other of these products. It's an AI powered platform that's aggregating and synthesizing and visualizing peer-reviewed medical literature. So we can try here if I can remember. So it's going to compile a summary and that will link to things like FDA labels and the primary literature. And the nice thing is that you're going to be looks like it didn't like that. Let me try going to Chrome and see if I can get in there. It is going to it's going to link you to, it's going to indicate if the information is from a leading journal. So that's like with an impact factor in the 90th percentile. It can generate potential follow-up questions. It can do a lot of things. It can create patient handouts. It can compute common formulas, ask about treatment options, research a topic, ask for guidelines to consider. One thing that we just want you to be aware of is, and it's pretty hidden, is their privacy policy. So you can find it if you're not logged in on the very bottom of their homepage. So their privacy policy indicates that OpenEvidence is an experimental technology demonstrator. It does not provide medical advice, diagnosis, or treatment. And of course, user questions and other inputs on OpenEvidence are not covered by HIPAA, right? So again, and we're still not really like exactly, we know a little bit about the corpus. It includes the New England Journal of Medicine corpus and other clinical documents, but the full list hasn't really been shared. I watched this like very long CNBC video about it by the founder, and they just say the same thing that all these companies say, which is basically it's trained through specialized medical content, which we achieve through strategic partnerships. So there's like not real like transparency there. So just all things to be aware of when you're thinking about using a tool like this. What else can I tell you? It has an app, which might be nice. But okay, so those are our tools. We're gonna, I think, head back to our slides to kind of wrap things up. And please, one thing I just wanted to point out is we're really weighing where to go with recommendations for researchers in terms of these tools. We're just still exploring them and whether we should consider licensing them. One AI-related product the library provides access to is Trinka, which is an online grammar checking and language correction AI tool. It's like Grammarly, and you can register for an account. You can just go to trinka.com and register with your MSK email, and then you will receive an email telling you to activate your institutional access. And it uses natural language processing algorithms to analyze and enhance academic and technical writing. Let's see, Joanna, do you want to?
Yeah. Do you want me to share my screen or are you good?
I'm good. Yeah.
Okay. Do you want to put it in presentation mode? It might be easier to see. There's so much text on the slide. Thank you so much. So one of the promises of this class is you talk about who's using generative AI. And here is one answer. This is from Pew. And I think this data is pretty recent. So they found that the people, yes, so this was published in February. It's based on data from a survey in October of 2024. And they found that among people using AI chatbots for work, most people are using them for research, which seems like what a lot of you have been doing. Some of them are using them to edit written content. So Trinka is on the right track, apparently, in terms of the market share and what people want it for. Most are using these tools to save time, but they don't find that they're necessarily improving their work quality. And most of the people using these tools are young and well educated. So I feel like the use in the research setting where we are is really similar to what Pew found. Clinically, I'm not sure what a survey would find, but we are in good company here. So we started with an example of how not to use generative AI, and we're going to also end with one. This is an example of how you shouldn't use it when you're writing. There's a French researcher whose name I'm going to butcher, but I believe it's Guillaume Papanak. And he searched for within papers, I think within PubPeer, which is a database of papers where people can give their feedback. Often it's a place where people go if they're trying to determine if a paper has critical errors. Anyway, so he was looking up two phrases. One was regenerate response and ChatGPT, and the other was as an AI language model, I. And for the first one on the left, he found it in 53 papers, and the second one on the right, so far in 20 papers. These are getting published. People are using chatbots to write papers, to publish papers. This is not what we should be doing. So just a reminder, if you use tools for literature reviews to summarize what's out there, make sure to be transparent about it. Don't cut and paste what that tool had to say into your paper that you're going to try to publish. And people are doing that, and we're sure that more than these 73 people are doing that. So just because people are getting away with it doesn't mean that we should be doing it. If you want to read more, we link to a Retraction Watch article about this work at the bottom. So that brings us to this flowchart, which in the absence of a validated instrument for appraising the quality of AI tools, this is what I sometimes do, is just ask myself these questions. So starting of, what do you need this for? Do you need to find all the available evidence on a topic? Are you doing maybe a guideline or systematic review? And if the answer is yes, then I would say a generative AI tool is not what you should be using to do that project. Maybe in the beginning stages when you're trying to brainstorm or figure out what's out there or figure out other ways that you might want to frame your question for your project, it might be helpful. But on the whole, it's not going to do that work for you. If you want to make sure your sources exist, then you're not going to want to use a tool like ChatGPT. You're going to want to make sure that you're using something that says what it's searching. And that if there's a clear gap or maybe an unclear gap because they're not clear about what they're searching, you're doing some additional research on your own to try to fill that void. And then if you know like the date ranges of what you want searched for your project, but you're not sure that the tool you're using is searching most recent. I know ChatGPT, at least the free version, does not include what like the past 2 years of data out there on the web. And there are some other tools that don't go back that far, some that are coming out from specific publishers that we don't have access to at this point, maybe only go back 10 or 20 years. So if you know that you want a specific coverage, you're going to want to make sure that you're using a tool that includes those dates. And if not, you're going to perform additional searches. We have 1 minute left. I'm sorry, Robin.
No, it's okay. So we just really quickly in the chat, we'd love to hear from you more, and we will, if you have additional questions, please put them in the chat too, and we'll follow up with you. We would like to know if you are going to, if you're going to be using them now, what type of projects, at what stage. If you're not, what's going to stop you? And, what would convince you other times? What tools do you want to learn more about? We want to learn more this will help us prioritize what we may license and what we will learn more about and have more classes on. So we'll send you all these our slides. So this is pretty, I think, self-explanatory. Just some more light reading. Always we're a resource for you at MSK Library. This is the easiest way to get in touch with us, ask us, go to our library website and chat with us, send us a question, email
Ask us
us.
to do a lit search.
Let's do a lit search. That's what we're here for. And these are our emails if you want to follow up with either of us directly. But of course, we'll be sending the slides to everyone else. But yeah, we will. Just thank you so much. We're really
Thank you
delighted
all.
to share this with you.
Have a great day.
Stop the recording.